स्टूडेंट्स, मैं डॉक्टर संगीता शर्मा। आज हम एमएससी फाइनल 9 पेपर फिजिकल स्पेशल की यूनिट 5 में एक्सटेंडेड हकल थ्योरी को पढ़ेंगे। The Huckel methods perform the parameterization on the Fock matrix elements and do not at the integral level as do NDDO, INDO and CNDO. This means that Huckel methods are non-interactive and they only require a single diagonalization of the Fock-Huckel matrix. The extended Huckel theory or method developed primarily by R. Hofmans considering only the valence electrons. It makes use of Folkman's theorem and assigns the diagonal element in the F matrix to be atomic ionization potential. The off-diagonal elements are parameterized as average of the diagonal elements weighted by an overlap integral. The overlap integrals are actually calculated, that is the ZDO approximation is not invoked. The basis functions are taken as Slater type of orbital with the exponents assigned according to the rule of Slater, which is given by these equations. K is empirical constant is usually taken as 1.75 as this value reproduces the rotational barrier in ethane. S is developed integral. The energy associated with the matrix element is proportional to average VSIP for two orbitals mu and nu. An essentially identical approach has been used for periodic system within the physics community, where it is known as tight binding models. Recently, this area has used to approach to parameterize against density function result, providing a computationally very efficient model capable of yielding fairly accurate results. Since the diagonal element only depend on the nature of atom, that is nuclear charge. For example, all carbon atoms have the same ability to attract electrons. After having performed a Huckel calculation, the actual number of electrons associated with atom A can be calculated by equation 2. The effective net atomic charge QA is a difference of reduced nuclear charge and the electronic contribution. QA is equal to Z-A minus rho A. Generally, it is not possible that all carbon atoms have the exact same charge because owing to the different environment, their ability to attract electron is not equal, which is inconsistent with initial assumption of all carbon having the same diagonal elements in the Huckel matrix. In order to get self-consistency, a diagonal element F mu mu belonging atom A may be modified by the calculated atomic charge, which is F mu mu is equal to minus I mu plus omega QA. The omega parameter determines the charge on the diagonal element. Since QA is calculated from the result molecular orbital coefficient, but enters the Huckel matrix that produces the results by diagonalization. Such scheme becomes interactive method where the matrix elements are modified by the calculated charge are often called charge interaction or self-consistent Huckel method. Similar self-consistent charge models are used within the tight binding formalism. The main advantage of extended Huckel theory is that only atomic ionization potential are required and it is easily parameterized to the whole periodic table. ETH can be used for large systems involving transition metals where it is the only possible method, computational model. The very approximate method of ETH makes it unsuitable for geometry optimization without additional modification or calculation of energetic features at any reasonable level of degeneracy. Primarily used for obtaining qualitative correct MOs, which can be example by use as an initially Gaussian of the density matrix for ab initio SCF calculation or for use in connection with qualitative theories. Orbital energies in many cases show the correct trend for geometry perturbation corresponding to bond, bending or torsional change, and this quantity features regarding molecular shapes may often be predicted or rationalized from EHT calculation. One of the drawbacks of EHT is it is failed to take into account electron spin.